networking, troubleshooting networks. As we reach the end of these videos in this lesson on networking, we need to discuss how to troubleshoot networks. And this is a pretty large field, and people spend their entire, years and years and years in their entire careers studying troubleshooting networks. So specifically, I'm going to focus on some of the more common problems that I see pop up in the test. And also, I'm going to look at the command line tools that pop up on the test, specifically in how you can use them to troubleshoot. I may be going into the Windows environment at some points here, but most of what I have to say is going to be expressed on the slides. So we're going to begin this discussion, as I just mentioned, with a look at the command line tools you can use when troubleshooting your network. Specifically, these are IPconfig, our sort of most general tool that allows us to get the configuration of our IP addresses. Ping, which can test connectivity. Traceroute, which is an advanced form of ping, which allows you to see basically the path a packet takes as it goes from one location to the next. Netstat, which looks at the network statistics on a specific computer, particularly ports that are open. And nbstat, which I highlight here because it has to do this NBT, which is for NetBIOS, a Windows-based naming service that we'll talk about, but specifically this is to look at Windows names, just like DNS, Domain Name Service, allows you to convert google.com to an IP address. Netstat is what NBTstat or NetBIOS. NetBIOS is what you use to look at Microsoft names of computers. So your computer has a name, Josh's laptop, that uses NetBIOS when it goes out on the network. And then I also want to look at nslookup, which is directly related to domain name service. That's the name service lookup. So that would look up, for instance, what google.com's IP address is. Finally, I want to look at the net command, which we have talked about when we talk about services or with using mapped drives. But it's a pretty popular command, and it's one I want to address just again. Then I want to look at troubleshooting some common symptoms in Windows environment, specifically with networking, including no connectivity, limited and intermittent connectivity, slow transfer speeds, which we could also write as high latency. Remember that word latency we looked at. A low RF signal, specifically in terms of Wi-Fi. And an IP conflict, meaning that there's more than one IP address on a network, which can happen when we're using static IP addresses, not so much with dynamic, because the server would make sure we don't have more than one IP address. We're also going to look at the use or what happens when we have an APIPA address. Remember, that's that self-assigned IP address that a computer gets when it can't find an IP address from a DHCP server. So let's start with the command line tools. These are extremely useful, especially in troubleshooting network situations, and that's really because with so many versions of Windows, it's hard sometimes to find the information we need and to get there quickly. And with a command line, if you know a few tools, you can get the information you need really quickly without having to open up any GUI interfaces, which is why they're still one of the preferred methods of troubleshooting on computers today. You always want to make sure you run the command line as an administrator or an elevated mode. And remember, we do that by right-clicking on command line and clicking run as administrator. We also need to know some specific tools that we just talked about for the A+ exam. So there are some others out there that we're not going to cover. These are the ones you need to know for the A+ exam. All right, so before we get into IPconfig, let's go over into Windows, and we're going to go to Start. We're going to right-click the command prompt and go to Run as Administrator. So now we have it open. I'm going to go ahead and CLS, which is clear screen. And just for the sake of being clean here, I'm going to make sure we go back to our root directory. So now we're in C. So first let's talk about IPconfig. IPconfig stands for the Internet Protocol Configuration, or IP configuration. It displays current TCP/IP network configuration values. So you can see, for instance, here we have all of this information that we can get. including our IPv6 address, IPv4, subnet mask, default gateway, and so on. It's the first tool you want to use when you're troubleshooting a network because this will tell you, is the computer getting an IP address? If it is, then you know that half of the problem doesn't exist. There is no problem, right? And so we can start to narrow down what the issues are. If I can't get out to the internet, but I have a valid IP address, I know the problem isn't internal to my network. It must be the connection that my router is getting from the network or from the ISP. There are also several switches that you need to be familiar with. The first is IPconfig all. So let me just take a second here and go over. We'll just run IPconfig in the Windows environment just to show you. So we're here. I'm going to go IPconfig and automatically get all this information. I'm going to make this a little bigger just to help us. And what you'll see is that you get IP configuration for every adapter that is on the computer. So I have a Bluetooth adapter. That, of course, would give me some information. It's disconnected right now. Local area connection, etc. Tunnel adapter if I'm using VPN. And then others that are specific to software and such. Now, what you'll notice, I want to point out here, is that you're only getting the IP address, the subnet mask, and the default gateway. You're not getting any other information. And so if we go back and we looked at IPconfig all, and you can see a screenshot on the right, this shows us a lot more information, including the DNS server, which was not included originally, and the MAC address, which you will call as the physical address. You already have the gateway, which is provided. So if we go over into Windows, we see here the information we have. And now I'm going to clear screen this, and if I run IPconfig all, look at how much more information appears. The most important one that you really want to pay attention to, in my view at least, is this one, the physical address. It'll also tell you whether DHCP is enabled and some other information, but I think the most important thing this can tell you is the MAC or the physical address of the adapter. And that's something you definitely want to take into consideration. So that's a pretty important switch, giving you a lot more information. There are a few others that you should be aware of. The first is IPconfig release, which releases the current IP address. Now, let's say that I had a bad IP address, or I have a dual IP address. I'm having an IP error, which we'll talk about. But for some reason, I have somehow gotten an IP address another device already had. I could use IP release to release that IP address to another device. I could also have renew. Now, renew will renew the IP address. So whereas release just lets go of it, renew actually lets go of it and then asks for another. In that way, renew is a little more useful. And finally, IPconfig flush DNS erases and repropagates the DNS settings. So if you're having trouble, for instance, getting out onto the internet, perhaps the problem isn't that you're not connected, but the problem is really that your DNS has been poisoned somehow and is sending you to the wrong sites. So by flushing the DNS, it erases all the DNS settings and then allows you to repropagate that. And if we go over to Windows just really quickly, I could do IPconfig renew, which is going to renew the IP address that I have, and IPconfig flush DNS automatically just tells you it successfully flushed the resolver cache, and the cache being that information it's storing on the computer. So now every time I go out to a site, it's going to begin to repropagate that data from off the internet. Now, with IPconfig, we can troubleshoot with it, because if we can tell if a computer is receiving an actual IP address from a DHCP server, or if it's being assigned an APIPA or self-assigned address. If it's being assigned a self-assigned address, then we know whether the IP address is actually real. We can also determine whether the IP address is private or public. If we go over and look at the IP address I'm getting right now, by doing an IPconfig, you'll notice it's the 10.0.1.28. Well, as you recall, that is a private IP address, so I am behind a network. I'm behind a router. If I was getting a public IP address, then I would know I'm connected directly to the ISP, and this could tell me that something might be wrong or different in my setup. I also could tell if the user can't connect to any websites, but it can connect to other computers on the LAN, then the DNS server address is probably not configured correctly, and by releasing and renewing the IP address and by flushing the DNS, that's going to help fix that problem. Okay, the next one I want to talk about is ping. Ping, it shares the same name if you've ever watched like a submarine movie. It tests whether another host is available over the network, so it can see if that network is live or not. So you'll see here I pinged google.com, and it says with 32 bytes of data, which is the standard packet size, and you can see it's getting a reply with a certain time to live in bytes. The reply indicates the host is alive and it can be communicated with. If you get a request timed out or destination host unreachable, then that probably means that the host is down or it's been configured not to accept ICMP packets. ICMP packets, by the way, which we'll talk about in Network Plus, are the packets that ping sends out. So, if we go over to Windows again, and I clear screen, you can see as I ping google.com that I'm getting a response. However, if I ping Microsoft.com, you'll notice that I get a request timed out. Now, one thing this could tell me is, this probably means that Microsoft's website is down. But if we go on the internet and try to go to Microsoft.com's website, you'll see it's working perfectly fine. So in this case, they have actually configured their routers and their servers not to accept pings from ICMP packets, which is the reason why this is not working. This also gives you the time that the ping took to travel to and from the host. You see here it says 8 milliseconds, 92 milliseconds, 12 milliseconds, etc. And if I'm getting very high numbers, if I got a lot of 92s or 400s or something, then there might be some latency issues as well. And if we go back over real quickly, you'll see here that the time to live, the time it took was actually pretty small. And again, this could suggest latency issues. So some of the switches you want to know, one of the biggest ones you want to know, and by the way, with this one we use the hyphen instead of the slash. I'm not sure of the reason for that, but that's the way it's always been. Ping/t will ping the host until the command is stopped manually. So you probably want to use that if you've rebooted a computer and you're waiting for it to come up. And so if we go over there real quickly, I will initiate one for you. Let's ping google.com. And what will happen is it's going to keep, usually it only gives 4, but it's going to keep pinging. And it just keeps going until I press Control-C, and then it will stop. Ping N pings a host a specific amount of times. So you could specify I want to ping it 10 times or 20 times. There are some benefits to using that. I wouldn't worry so much about that one for the exam. The one you really want to know about is the ping/t. That's the big one. There's also ping L, which pings the host, but you can specify the amount of bytes you want to send. As opposed to 32, you might want to send 64 or something. That could be for a bigger test. Again, the one I would really worry about is ping T, which will continually send pings over and over again. Remember, you can always do ping ? For help, and that will tell you all the switches. Now we can use ping to troubleshoot. Specifically, it's really useful to test whether or not TCP/IP has been installed properly, and we can do this by using the loopback address. You remember we learned when we were talking about TCP/IP that these addresses, these IP addresses, this one for IPv4 and this one for IPv6, can be used to basically ping yourself. They are the IP addresses that represent yourself. And if we go over to Windows and we type in a ping 127.0.0.1, you'll notice it's going to ping us and the time takes less than 1 millisecond. Interestingly, you can also ping localhost. That is the NetBIOS name of the 127.0.1. And if we ping that, you see it's pinging itself. Now with the IPv6, the same thing. And it also works. We can also use ping to verify that a computer, as I mentioned, is back up after a remote shutdown or for remote control purposes. So if I've rebooted, say, a server that I've been working on, I can use ping to verify it comes back up so then I can remote in and do what I need to do. All right, let's talk about traceroute. Traceroute, which is condenses that RT from route. It builds on ping by sending packets to a destination beyond the local computer's network, and it tracks the route it takes. So what it does is it pings each router along the way between you and the final destination. So every time it hits a new router, it sends back information to you, so then you can determine where, for instance, we're losing connectivity if I don't have connectivity. So where a bottleneck occurs or where a connection is failing. And if we go into Windows real quickly, let's try tracing the packet from us to Microsoft.com. So what you'll notice, and we can see when it times out. So I have this time capsule, which is 10.0.0.1.1, which is my router. And then it seems like it's going off into my local ISP, and now it's going out into other servers, right? And now here you can see it probably hits some sort of Microsoft server. And so what's going to happen at this point is it's going to stop giving us information. Now, if we do this with Google, on the other hand, let's clear this. We should see the first few should be exactly the same because it's going out from us, and then it's going out to our network. And now it's out on the ISPs. These are the same things we saw before. And now we're starting to not get some information here because there's probably some stuff along the path it doesn't want to show us. But here we still have some IP addresses and so on. This will keep going until we reach google.com server, and we could see where any hiccups are on the path it's taking. We can also tell that it only takes 10 hops, that's what we call this, 10 hops to get between me and Google. So that's like 6 degrees of separation, right, of Kevin Bacon. This is 10 degrees of separation to google.com. The next one I want to look at is netstat. Netstat gives you current network statistics. It shows you open sessions to the local computer. This includes which ports are open. You can also see what network services are currently running, and perhaps some shouldn't be. So you can see over here, it shows if I ran a netstat, and I can run this on my computer as well, that it shows 127.0.0.1 is the local address, meaning it's from my computer, and the port that's open is 5354. And then what I could do is I could go on to the internet and search what that is. Interestingly, you'll notice that the 5354 here matches to this one and this one to this one. So this is probably an internal connection made from my computer to itself and back again. These probably create like a figure-8 loop. And if I was having an RDP session, I would see 3389 on there. If I had an open FTP server, I would see 25. And I would see the foreign address be the foreign computer that I'm connected to. Now, different from this is nbstat. nbstat shows the network statistics over TCP/IP connections using NetBIOS. And again, NetBIOS is like DNS, but is specifically for Microsoft networks. Just like I said. So what you can do is use the A switch to show what the services running on the local or remote computer are. And I would recommend that. So what you'll see is this says nbstat A, what services are running on the IP address 192.168.1.105. If you ran it without that, it would simply give you your own statistics. So this allows you to do it for another computer. It calls this the name table, by the way. So this shows the name and the type of computer it is and all the remote machines that you are currently connected to. Now, nslookup is the name server lookup service, and it queries a DNS server to discover certain details about DNS. Plain and simple. So if we go over and take a look at this, I'll clear out of this, nslookup. Now, nslookup runs slightly different from the other tools. You do nslookup, and that takes you into an nslookup utility. You'll see that it says the default server is 10.0.1.1. That's where it's going for my DNS server. And now I could look up information. For instance, yahoo.com, and it'll say, oh, these are the 3 IP addresses that could get you to yahoo.com. Or we could do google.com. And these are all the IP addresses, including looks like an IPv6 address. These are all IP addresses that can get you to the google.com server. And we could go on, so forth, and so on and so forth. Control-C, by the way, will generally get you out of that. All right, the net command. This is actually a collection of commands. It's not one, because we've seen it in a few instances. And what it is you have net, and then the next word defines what kind of command you want. Net view lets you to see which computers are currently on the network. So if I was to do net view, as you can see I did to the right, you'll see these are all the devices that are available on my current network. If I do it right now, net view, you'll see there's only 2 devices on the network, myself and my router. Net share is what we used, remember, to share or map drives. I'm sorry, to share folders on your computer. Let's go back. Net share allows you to share folders so that other people can view them, just like right-clicking on a folder and going to share. And net use lets you map network drives, which we already looked at. By the way, net start and stop allows you to start or stop services, like we looked at when we talked about printers. And if we go in and just review that real quickly, I can say net stop spooler, which will stop the spooler service. And then I can net start spooler to start the spooler service. So now we've talked about some of the command line tools used in troubleshooting networks, including IPconfig, general configuration data, ping, traceroute, ping, which verifies connectivity, and traceroute, which traces the route a packet takes, netstat, showing the current network statistics, nbstat for net BIOS statistics, nslookup for our DNS servers, and then the net command, which is actually a series of tools. Now let's look at troubleshooting some of the common symptoms. So first let's talk about no connectivity. The first thing you want to do is verify your physical cables, making sure you replug them in, using a cable tester, etc. You also want to make sure the network adapter is enabled in the device manager, right? So if we go into Windows, I need to make sure, if I right-click on Computer, go to Properties, and then I go into my device manager, I need to make sure that my network adapters are all running properly. And you can see here there's no problems with any of them. If it's a laptop, and this is an important one, I see this pop up on the exam all the time, okay? If you have a laptop and the user has wireless, make sure the Wi-Fi switch or button is switched to on. Otherwise, the wireless card is as good as disabled. But from a hardware point of view, not even from the device manager. You can also ping the local computer to make sure TCP/IP is installed correctly. It could be all the hardware is connected, but the protocols, the TCP/IP protocols, aren't connected, which is not allowing you to connect. Finally, I would verify the internet source is on and working, meaning you can ping your router or your gateway. You could also try to reboot the computer. This would reset everything. This is generally a pretty good step. You can find out from a user if any programs are recently installed or updated and roll them back, again using the add remove in XP programs, or the uninstall applications sort of option in Windows 7 or Vista. Sometimes an antivirus software or firewall software updates can cause connectivity issues, so be aware of that, and if something happens, most of the time though you're going to be able to fix that by simply rebooting the computer. You also want to make sure you're connected to an enabled port on a switch or router. Sometimes you can disable a port from a switch or router, and you want to make sure the one you're connected to is enabled. Basically, the idea is check all the physical connections, then start checking the software connections, and then, if nothing else, talk to your ISP. You can also always test with a device you know works as well. You can also, if you know that your SOHO router isn't working, or your cable modem or your DSL modem, unplug them all, replug in the cable modem, replug in the SOHO router. Now, if you have limited or intermittent connectivity, this is different from no connectivity. The first thing you want to do is ping the local host to see if TCP/IP is functioning. Because limited or intermittent connectivity means there isn't a permanent big problem, like you're not plugged in. It means something is going on and off, which is weird. You can also ping the router or another system on the network to see how far your connection is allowing you to get. If that fails and the user only has local connectivity, so if I can't ping the router or another system on the network, then something's wrong, right? If pinging the router does work, try to ping a website. So again, here's my computer. Here's my switch. Here's another computer. Maybe here's the router and here's the internet. First thing I want to do is test, does this work? Yes, that works. Now test, does this work? Yes, that works. Now test, does this work? Oh no, that doesn't work. So we guess the problem is probably here. If that does work, then you can go out some more. If you can ping the website by name, then you're probably not having an issue at all. If you can't ping a website by name, then you're probably having a problem with your DNS server, your name server, right? You can get out to the internet, but it just can't translate between names and IP addresses. You might also want to try IPconfig renew to get a new IP address. A lot of this is common sense based on the stuff we've already talked about, so this is sort of a conglomeration of all of the stuff we've discussed. You can't have more than one IP address on the same network, as we'll see. So sometimes if another device comes on, it has been assigned a temporary IP address or a dynamic, and then another device comes on that has a statically assigned IP address, and it's the same one, that can cause an issue. It could also be due to physical issues, faulty patch cables, wireless and network adapters too far from the access point, etc. If you can access some networks but not others in a larger area, then use traceroute to determine where the problem is lying. That's the best thing about traceroute. It'll tell you when the device drops out. Now, if we're dealing with slow transfer speeds, this is probably more related less to your network and more related to old equipment, network congestion, or even the internet connection, depending on how large this is. At home, it's probably related to your ISP. At a bigger place, it could be related to, a lot of traffic or old switches or old hubs being used instead. You can always run a netstat A to see what connections the local computer has to the internet, and maybe if you have unnecessary ones, then that's where the problem occurs. If I run netstat A or nbstat A and I see a lot of problems occurring or a lot of connections, then I probably have some sort of compromised system. You also want to always try updating all your software, clearing all your caches, maybe even power cycling everything, and that should fix the issue. If I have a low RF signal, and this is definitely related to access, a wireless access point, first check the distance. It might be that you are too far and it's just not going to work. You want to make sure, as we've mentioned, that the access point is in a central location and away from anything that's giving off a lot of EMI. You may also want to consider upgrading to a new wireless adapter. You know, a lot of wireless access points are really not that expensive. And so it doesn't hurt to spend $50 if that's going to get you that much more internet connection, you know? And you want to update the software on the wireless adapter and on the access point to the latest firmware versions, and that can help some speed issues as well. Sometimes you can also try using a different channel. Now, if I have different IP conflict messages, you're going to get a message that pops up and says there's another computer on the network with the same IP address. The first computer that uses the IP address is going to continue to function. The second one that's trying to join, that one's not going to work. This usually only happens when you're using static IP addresses, which means you've self-assigned an IP address. So what you generally want to do is use a DHCP in order to have this all automatically configured for you. Now, if you're getting an APIPA address, this is the same generally as no connectivity, right? If you get that APIPA address when you type in IPconfig or IPconfig all, then you're failing to get an IP address from a DHCP server. So, what are our problems? Well, this means, and by the way, remember, APIPA addresses always start with 169.254. So the real problem is the computer's not getting connectivity. Maybe you're not plugged in. Maybe the DHCP server is down or your router is down. No matter what, the problem if you're getting a APIPA address is that it can't find a DHCP server. And any problem that could cause you not getting to a DHCP server, whether the DHCP server is down, whether your switch is down, whether your cords are down, any of that can be the actual problem. Great. So now we've finished talking about troubleshooting common symptoms. We looked at no connectivity, limited and intermittent connectivity, slow transfer speeds, low RF signal, IP conflicts, and APIPA addresses. Let's go back over all these, starting with the command line. So we talked about IPconfig, which is used to give you your IP address, more or less. If you do this /all, don't forget that'll also give you the physical address. A ping, right, that's to test the connectivity. And by the way, I have seen it where they will show you the output of a ping and ask you what tool this is. So it's good to sort of go through these and just know what kind of tool it's giving you or what kind of output it's shooting out. Traceroute traces the hops and can tell you where bandwidth or where latency or where an issue is occurring. Netstat shows you the statistics on a computer. Specifically, it looks at open ports. nbstat, the reason I most see this is having to do with NetBIOS, okay? If you see NetBIOS, just go straight for nbstat, that's the answer. And remember, those are the Microsoft names. So this will tell you, for instance, what computers or users are connected to you. nslookup is to get DNS information. And then the net commands, which can be used, remember, to share out something, to use something, or to start and stop a service. We then talked about troubleshooting common symptoms, including no connectivity, which could be a physical issue, or it could be, you know, anything. Try pinging your TCP/IP, but generally I'm guessing that you're not even connected. Limited and intermittent connectivity, which generally means you're connected but not getting an IP address, or connected but not getting out to the network, which could be a problem with the router. Slow transfer speeds, check your distance, check your caches, etc. Low RF signal, upgrade the firmware. Or centralize the access point. IP conflicts mean that you have more than one IP address. Generally, restarting will fix the problem, but you want to make sure everything is set up DHCP if possible. And an APIPA address generally means you're not getting connectivity or having limited connectivity. So check, you know, everything between you and the DHCP server. If there is a DHCP server, that might be the problem. Okay, so now we've talked about all of the networking stuff. Let's get into security to secure this network that we've just created and troubleshoot.